So we're going to start this Chapter 2, Section 4 out with a story problem. Mr. Seals weighs 101 pounds and is gaining 8 pounds each month. Mr. Thomas weighs 205 pounds and is gaining 4 pounds each month. In what month and year will Mr. Seals weigh the same as Mr. Thomas? Take about 5 minutes to think about this problem and try to figure out the answer. And you can do this any way. You don't have to make an equation. You can come up with it with any method you want. So go ahead and get started on it, and I'm going to pause it and then come back when you're ready and we're going to move on. So what I want you to do is first, before we move on and answer this problem, figure out what you used, what method you used. Did you just try to throw in a bunch of numbers? Did you strategically figure it out by this method? Think about the name of the method you use, because more than likely what you used is what a lot of people might use in the same situation. And what would that be called? And see if it matches up with what we're going to figure it out, with how we're going to figure it out. We can figure it out with a table, a graph, or an equation. I'm going to show you each one. First, if we wanted to make a table, this is what one would look like. It doesn't have to be exactly like this. The columns could be in different orders, but basically you want to keep track of how many months you have that have gone by. You want to keep track of Mr. Seals' weight, and you want to keep track of Mr. Thomas's weight. And so at 0, we're at 101 and 205 pounds. 1 month later, I add 8, he adds 4. A month later, I add 8, he adds 4. And we keep going along until we have the same amount. You'll notice that it takes a while. It'll actually take 26 months, that's what this represents, to weigh the same. And the great thing about this table is it will tell us how much we weigh at that time, which isn't the question we were asked, but it's extra information we could know. So we would both weigh 308 pounds 26 months from now. Another way to do this would be to graph. Now, this requires a little bit of setting up before we could do it, because we need to know what our maximums on each coordinate is. This x coordinate would be in time in months, and so we need to know, let's say, I could go out to 75 months and I might not have my answer yet. So we need to kind of have an idea of what our answer would be. So just a rough guesstimate. And if it's wrong, we'd have to change it. And then the weight in pounds, we could have been 550 pounds before we were the same. So it's not an exact thing, but you gotta have a good window here. If you're stretched too far out, it's all squished in the bottom. If you're too far in, then your solution isn't going to be on the graph. So here's what we have. There's a line that represents my weight, because I go up 8 pounds every month. Up 8 pounds every month. Up 8 pounds every month. It's pretty steep because I'm gaining a lot of weight every month. Mr. Thomas's is a little more shallow. He goes up 4 pounds every month. And so what happens is I'm catching up to him as time goes along. The solution, where we're the same, is right here at this intersection point. And guess where this point is? It's 26, 308. And that represents the month that we are the same weight and the weight that we are on that month. Now, that would be, since I gave this problem in October, when I did this in class, you add 2 years, which is 24 months. That would be October of 2017. And then 2 more months beyond that, November and December. That would be December 2017. The last one is we can make an equation out of this. And this is where this chapter comes into play. We have to figure out how to solve equation with variables on both sides. My weight I gain per month is 101 plus 8m, and m represents how many months have gone by. So if 2 months have gone by, you'd put 2 here. 8 times 2 is 16. We gain 16 pounds in 2 months, add it to our original weight. Mr. Thomas's is similar, but he starts at a different amount of weight, and I add 1 per month that we go along. In order to find where we weigh the same, or when we our equal weight, we need to set these two equal to each other. It would be 101 plus 8m equals 205 plus 4m, and then we would solve. So we have variables on both sides, so we need to figure out how to solve this equation. Well, you need to treat 8m and 4m like one term. There's lots of ways to do this, but either way, you have to remove a common value of terms from both sides. That means I need to either take away 4m from the right side and 4m from the left side, and that'll get rid of the 4m on the right side, or I can take away 8m on the left side and 8m on the right side, and that'll get rid of the m's on the left side. Whichever way I do it, I got to make sure I remove all the m's. And when we remove an entire term, which is the number in front called the coefficient and the variable, those two together, when we do that, you just subtract them. Because 4m minus 4m is 0m, and that cancels out. 8m minus 4m, because we balanced the equation, is going to be 4m left. So I've got 101 plus 4m is 205. Now it's a two-step equation. Now we solve. And the answer is 26. Same thing that came up in our table. Same thing that came up in our graph. Notice that this is something this does not tell us is how much we would weigh at 26. In order to find that out, what you'd have to do is put 26 in right here or right here. In either side, you're going to get 308 and you're going to get 308. 8 times 26 plus 101 is 308, and 4 times 26 plus 205 is 308. So try to solve this problem. 6x plus 3 equals 8x minus 21. 6 times what number plus 3 is 8 times the same number minus 21. Possible answers are A, -3, B, 12, C, 5, D, 14.7. Okay, similar examples of those types of problems would be on page 98, numbers 3 through 16 all. Work through some of those, please, if you need help.